First, I measured out 100 milliliters of hot water. Next, I measured out 50 milliliters of cold water. Immediately before mixing, I want to get the temperatures of both the hot and the cold water. The initial temperature of the hot water measured 65.3 degrees Celsius. The initial temperature of the cold water measured 17.6 degrees Celsius. That tells me that the hot water molecules were moving faster on average than the molecules in the cold water sample. As soon as initial temperatures were measured, I mixed both the 100 milliliters of hot and 50 milliliters of cold water together and took its temperature after swirling it around. The mixed temperature came out to be 48.5 degrees Celsius. From the data we collected, we can determine how much energy was lost by the hot water and how much energy was gained by the cold water. Here is the data from the cold water. We started with 50 milliliters of water, and using the density of water, that equals 50 grams of water. Its initial temperature was 17.6 degrees Celsius, and the final temperature, which would be the mixed temperature, came out to be 48.5 degrees Celsius. The specific heat, or the C, of water is something that can be looked up, and with joules is 4.184. Using the QMCAT equation, I plug in my mass, my specific heat, and my final minus the initial temperature. You should get an answer of 8,556.28, but rounding with the appropriate sig figs, it would be 8,560 joules. Notice that it is positive, which means heat absorbed. Here is the hot water data. The mass of the hot water would be 100 grams, since we started with 100 milliliters. The initial temperature was 65.3 degrees Celsius, and the final temperature would be the same as the cold water, since it is the mixed temperature of 48.5 degrees Celsius. Once again, the specific heat for water is 4.184 joules per gram degree Celsius. Using the Q equals MCAT equation, we plug in the mass, specific heat, and the final minus the initial temperature. For this one, you should get a negative number, negative 7,029.12, or rounded to the appropriate number of sig figs would be negative 7,030 joules. Here, the heat was lost. Overall, we found out that the heat gained by the cold water was about 8,500 joules, and the heat lost by the hot water was around 7,000 joules. Now, in all reality, these numbers should be identical, just opposite signs. So that must mean that, well, I made a few lab errors. So see what you can think of that could possibly be a lab error that would have caused this little bit of error in our calculations.